Hi class, in lesson 15.5 we will be designing and implementing an experiment. Learning target for today, we will be analyzing data recorded during an experiment and answer questions that were posed at the beginning of the experiment. Let's take a look at page 1054 and problem number 1. We will be conducting an experiment to answer a question. It says that Miss Nicholson, the Phy-Ed teacher, has just had a new rock climbing simulation wall installed in the gymnasium. Wearing a safety harness attached to a rope, students can climb the rock wall, ring a bell at the top, and then make their way back to the ground by using the rope. You want to conduct an experiment to determine whether the students in Miss Nicholson 6th grade Phy-Ed class are better rock climbers than the students in her 7th grade Phy-Ed class. Which class between Miss Nicholson's 6th grade Phy-Ed class and her 7th grade Phy-Ed class has the fastest average rock climbing time if each student is given one attempt? So the first thing that I want us to do is take a look at number 1 and answer, is the question shown a statistical question, and why or why not? So go ahead and do number 1 with your group. If we take a look at the answer to number 1, yes, this is a good statistical question because data must be collected in order to answer the question. We must ask a sample or population of people in order to conduct the experiment because we do not know the answer to the question. You conduct the rock climbing experiment and record these times displayed in the table. So you can see here that we have the 6th grade completion times in seconds, and we have the 7th grade completion times in seconds. If we turn to page 1055, we are going to look at number 4, and using the times displayed in the table for the 6th and 7th grade classes, we want to construct histograms for the rock climbing times of each class. Do not forget to name your histograms and label the axes correctly. I also would like you to do number 5 using what you know about distributions. So it's either going to be symmetric, skewed right or skewed left, and patterns. You're going to look for gaps or clusters. What conclusions can you also draw about the class that has the fastest rock climbing time? So make sure you answer all 3 of those parts for number 5 as well. So go ahead and do number 4 and 5 on page 1055. Let's look first at the histogram that you had to construct for the 6th grade students. If we notice, we have the correct title, Rock Climbing Times of 6th grade Students. We have our axes labeled correctly with number of students and time in seconds, and we have our intervals that we have also listed for the number of students and the time in seconds for the histogram. Same thing for the 7th grade class. We have our title of the rock climbing times of 7th grade students. We have our number of students on our y-axis and our time in seconds on the x-axis. If we take a look at the answer to number 5, the 6th grade class appears to have the fastest times. This means that there are more times in the 40 and 50-second range and fewer times in the higher intervals for the 6th graders. The histogram for the 6th grade is also skewed right. The 7th grade times are symmetric for the distribution. You can see that more of their times are in the middle in the 60s. Let's turn to problem 2 on page 1056. Don't forget the 8th graders, they can rock climb too. Mr. Garcia, the 8th grade Phy-Ed teacher, also timed his students on the rock climbing wall. The students' results are shown on a dot plot. After analyzing the dot plot of the rock climbing times of the 8th grade students, I would like you to answer questions 1 through 3. How many students are in Mr. Garcia's class? Assume every student in the class was timed on the rock wall. And how do you know? Number 2, describe the distribution. So again, we are looking at either symmetric, skewed right, or skewed left. And we want to look for any patterns in the dot plot. So are there any gaps or clusters that we see? And finally, for number 3, what conclusions can we draw about the rock climbing times of Mr. Garcia's students? If we take a look at number 1, there are 32 students in Mr. Garcia's class because there are 32 different X's or data values that we see represented on the dot plot. For number 2, the distribution and any patterns that we see in the dot plot, we can see that the dot plot is skewed left because we see the data peaking on the right side of the dot plot, and there is data that is slanting off to the left. So distribution is skewed left. There are 2 clusters of data from 39 to 42 and from 46 to 50. There are gaps in the dot plot, 36, 38, and between 42 and 46 seconds. And finally, for number 3, a couple of conclusions that you can draw from the rock climbing times of Mr. Garcia's students. Most of them took about 46 to 50 seconds to climb the wall. A smaller number of students took 39 to 42 seconds to climb the wall, and there were only 2 students that took less than 39 seconds to climb the wall. So a couple of observations just on my end from the teacher manual. Any other observations that you put down would also be good as long as you are analyzing the dot plot correctly. That is going to be it for lesson 15.5 on designing and implementing an experiment. Please let me know if you have any questions. Thank you.